Hello and welcome back to this mini YouTube video entitled Dihybrid Cross, Inheritance of Two Traits. All right, so I'm going to turn this paper over real quick and I'm going to explain the situation. All right, so we have a brother and a sister, all right, who have fallen in love. Okay, bad news, right? Now, why is it bad news? Why is incest so bad? Well, incest is bad because recessive traits could possibly come through in the offspring of two closely related individuals. So case in point, let's take this male individual who has normal ears and a normal nose, all right, that's his phenotype, and this female with normal ears and a normal nose, okay? Now, the genes that we're going to be working with are the E genes. So the capital E, the dominant E, is for normal ears. The recessive allele, lowercase e, is for elephant ears. All right? Now, for nose, the allele symbol is capital N for normal nose, and the lowercase n is for elephant nose. All right? So if we take an individual who is, let's just say big E, little e, and cross them with an individual who's big E and little e, all right, we would have, as we've learned with the monohybrid cross, a 3-to-1 ratio of children, statistically speaking, with normal ears. And one child would have big Dumbo ears. Okay? Same thing can be said about the nose. All right? So cross two individuals who are phenotypically normal but are heterozygous. All right? And then you get a 3-to-1 ratio, and that would result in an elephant nose. All right, so let's take these, our young couple in love again, brother and sister, gross. They are doubly heterozygous. So let's check out their genotypes. Brother is big E, big N, little n. All right, and sister wife is also doubly heterozygous. Big E, big N, little n. All right? Now, before, when we were doing these individually, it was easy for us to just go, okay, big E, then little e. But now we have to consider how we can follow multiple traits at the same time. All right? And in order to determine all the possible combinations of these alleles, we perform a technique that's kind of analogous to the FOIL technique in algebra. Remember that? First, outside, inside, and last. So big E, big N, big E, little n, little e, big N, and little e, little n. All right? Those are all the possible combinations of these alleles that brother-husband can make when he is undergoing meiosis and making haploid sperm cells. What about sister-wife? Same darn thing, right? So let's go back to our dihybrid cross. All right? And here we're going to have a 4x4 grid. Across the top, we can put brother-husband, and across the bottom, or excuse me, the side, we can put sister-wife. And here's where we enter our combinations. Big E, big N, big E, little n, little e, big N, little e, little n. All right? Now what about sister-wife? Same darn thing. Okay? Now, you can determine what the genotypes are going to be of their offspring and the possible phenotypes of their offspring based upon a dihybrid cross. So you can do big E, big N, big N, right? For that combination. Big E, big N, little n. All right? Big E, big N, big N. So across this whole first row, big E, big N, little n. What would be the genotypes of these offspring across this whole first row? They would be normal, ears, and nose. Okay? Now, what about this first column? Well, down this first column, regardless of what these genotypes are, they're always going to inherit at least one big E and at least one big N. So all of these would be normal. So let's take an example of this individual right here. Big E, little n, little n. Oh, here would be an individual with normal ears and an elephant nose, right? Now I want you guys to finish this for yourselves, and I want you guys to tell me the ratio. Out of 16, how many are totally normal, like all these individuals across the first row? How many have only a messed up nose? How many have only messed up ears? And then how many individuals out of 16 would be totally messed up with both messed up ears and nose? So I'll let you guys finish that for yourselves.